Hey, it's Mr. Allred. I want to go through some of the special factoring rules that will not kind of fit the template of the AC method. Some of these will be quadratic, some of them will be cubes. But let's see here. The first one I want to go through is called the difference of squares. So this works if you have two perfect squares subtracted. If you have two perfect squares added, it does not work. So if we have just two terms, and we can write each as a perfect square, a squared minus b squared, then we can factor that into a plus b times a minus b. And you could multiply the a plus b times a minus b back together, collect like terms, and see what happens. It's the same thing. Okay, so the first example we're going to do here is 4x squared minus 9y squared. So we may not see that as a perfect square to start with, but if we look at it, we can rewrite 4 as 2 squared and x squared as x squared. So 4x squared is the same thing as 2x quantity squared. And then we have minus 3y squared can be written, 9y squared can be written as 3y quantity squared. So in comparison to what we have up above, the a is 2x and the b is 3y. So we wrote it as a squared minus b squared. So over here, we're going to write a plus b. So that's 2x plus 3y. And that'll be times a minus b. So it'll be times 2x minus 3y. Okay? So back here, here's an a, here's an a, here's a b, here's a b. But the signs are different in those two. The bottom one might seem a little bit easier. The first part is x squared. So that could be x times x. So we'll just say that's x quantity squared, and that x inside there will be the a. And then it's minus 25y squared, but we know that we can write 25 as 5 squared and y squared as y to the second power. So we'll write 25y squared as the quantity of 5y squared. So that'll be our b. So using the same formula, we'll have a, which is x, plus b, which is 5y. So x plus 5y times a minus b, which will be x minus 5y. So what we have in both of these situations are two perfect squares subtracted, and we call that a difference of squares. It'll let us break things up. Okay. The next two rules are the sum of cubes and the difference of cubes. So the sum of cubes works similar. You need two perfect cubes, except in this case added together. So the rule is a cubed plus b cubed, and that will equal a plus b all times the quantity of a squared minus ab plus b squared. And once again, you could use a distributive property to multiply that right hand side out and see that it collects. But let's go through an example here. So the example we have is 27 plus 8x cubed. Whether you know it or not, 27 is 3 cubed. It's a perfect cube. So 3 will be our a. And then it will be plus, now 8x cubed, that's a perfect cubed as well. It's 2x with the quantity cubed. So our b will be 2x. So now everything else is just dropping into that formula. So the right hand side is a plus b, which will be 3 plus 2x. And then the second product here, or term, will be a squared. So that'll be 3 squared, which will be 9, minus ab, which will be minus 3 times 2x, so it'll be minus 6x. And then plus b squared. b is 2x, so that will be 4x squared when I multiply it out. I got a little messy, so let me rewrite it. 4x squared. So let's see, if we label all this, this is a plus b, this is a squared minus ab plus b squared. Okay. These are just following a template, so you have to be able to find the square root of something or the cube of something, and it has to be really nice, or these formulas aren't very useful. The other one, the difference of cubes, similar. A cubed minus b cubed will break into a minus b, and that's all times the quantity of a squared plus ab plus b squared. So let's see here. We've got the expression 125x cubed. Well, that is a perfect cube. It has a cube root of 5x. So we got 5x quantity cubed. So 5x is our a in this formula. It's a subtraction, so that's what tells us it's a difference of cubes. And then we got minus 64y cubed, which is a perfect cube. It is 4y quantity cubed. So our b is 4y. So we're just going to drop everything in that formula. The first one is a minus b, so that would be 5x minus 4y. So I'll label that under there. And the second one is the big quantity of a squared, so that's 5x squared, so that would be 25x squared. And then that's plus ab, so that would be 5x times 4y, so that would be 20xy. And then the last part, b squared. B was 4y, so if I square that, I'll have 16y squared. So these formulas are not intuitive, but if you keep them handy or know where to look them up, it won't be any problem using them if you identify that you have a perfect cubed or a perfect square somewhere in there. All right, good job.